Right, everybody, how are you doing tonight? We're going to talk today about perpendicular and angle bisectors. We've learned the definitions before, we've used them before, we've constructed them before, but now we're going to look at the relationship with triangles. Go ahead and do this warm-up. It's all a review of perpendicular. Remember that slopes of perpendicular lines are the opposite reciprocals of the slopes of the line that they're perpendicular to. Pause it, then check your answer. Okay, if you have any questions on the answers, make sure that you get to me in class tomorrow. All right, so what are you going to learn today? Today you're going to learn the perpendicular bisector theorem and its converse, and the angle bisector theorem and its converse, and how to apply them. So what is a perpendicular bisector? Basically, it says that if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. So here we have the line PM. We've got the markings on the diagram that says it's got a right angle, so it's perpendicular, and then you have the markings to say that AM is congruent to MB. Okay, and then if that's true, we know that the distance between AP is the same as distance between B and P. So in symbols, that would look like this. Okay, so if PM is perpendicular to AB, notice that with AB, we don't use the lines because it's a segment, because lines don't have any distance. So if that's true, and then AM is equal to MB, then AP is equal to BP. The converse, remember in the converse, we switch the if and the then. So in this case, if PA is congruent to PB, then we know that PM is the perpendicular bisector of AP, and that point P, or MA, is equal to MB. And again, here it is in words. If a point is equidistant from the endpoints of a segment, then the point is on the perpendicular bisector of that segment. Okay, so there's the converse and the original conditional. So how are we going to use that? I see my line moved over there. So we want to find the length of QR. Remember that QR without the line segment over it just means the distance. So we learned that in chapter 1. And I keep hitting it, but you got to know, right? So looks like we have the conditions. I've got perpendicular, and then I've got bisector. So we got the conditions that we need, that we can say that Q is equidistant from both P and R. So we're going to set those equal to each other, those distances. 3n minus 1 equals 5n minus 7. Okay. And then we're going to go ahead and solve that equation. You guys can go ahead and solve it if you want. You know how to do it. Pause it, or you can just watch me do it. Pause this. All right, so got to subtract 3n from both sides, and when we subtract 3n from both sides, we're going to get -1 equals 2n minus 7. We're going to add 8 so that we get, we're going to add 7. I'm jumping ahead. So that we're going to get 6 equals 2n, and if I divide by 2, n equals 3. Okay, but we didn't want to find out what n was. We wanted to know what QR is, and since QR is 5n minus 7, I'm going to substitute 3n for n, and I'm going to get 15 minus 7, which I can do arithmetic, or I can't do calculus, but under arithmetic, you guys know that, that's going to be 8. All right. So we've looked at that example. Now let's talk about the angle bisector theorem. The angle bisector theorem says that if a point is on the bisector of an angle, then the point is equidistant from the sides of the angles. Okay, so if QP bisects angle PQR, and then we've got SP perpendicular to QP and SR perpendicular to QR, which we have, then we know that those are congruent. And we actually say that this is the distance from a point to a line is the perpendicular distance. And we'll talk about that in another unit, but just be ready for that. Give you a little heads up. Okay, and then of course we have the converse. You can look at the symbols. It just basically says if a point is equidistant from the sides of an angle, then the point is on the angle bisector of that angle. Okay, so let's look at a couple more examples, and then we're done for today. So we want to find the measure of FB. So here we go again. I got an angle. It's bisected by ray CF. So, and then we've got perpendiculars from that ray to the sides. So we know that BF is equal to FD. So we can set those equal to each other. 6x plus 3 equals 4x plus 9. Okay. So let's go ahead and subtract 2x from both sides, so that we've got 4x plus 3 equals 9. Okay. And then let's subtract 3 from both sides, so that we have got, oh my god, I am jumping ahead, guys, I'm sorry. Miss Craig is having a moment. So let's try that again. 6x plus 3 equals 4x plus 9. I'm jumping ahead. So I'm going to subtract 4x, not 2x, and it gives me 2x plus 3 equal to 9. If I subtract 3, I'm going to get 2x equals 6. Divide by 2, x equals 3. And then if I'm going to find FB, okay, I am going to sub that in, so I get 6 times 3 plus 3, or 18 plus 3, which is 21. And I don't want to stop and start over, because I've got all the kids that didn't go on your field trip today sitting in my room, and they're being really great about being quiet right now, and I don't want to keep them quiet for as long as they need to. You guys are now famous. You're on YouTube. All right, so another example, okay? What are the lengths of EF and EH? Again, we can see that they're on the perpendicular bisector, and they're actually marked congruent. So both of those lengths are 8. So that's kind of a no-brainer. But now we need to find Y, and I've got these two angles marked. But if we look at what we have, we've got two right triangles. We've got their hypotenuse congruent to the hypotenuse of the other, the leg congruent to the leg of the other. So by hypotenuse leg, we know that those triangles are congruent, or we could actually even say we know that EG is congruent to itself by the reflexive property. So it's also congruent by side, side, side. So to find Y, all we have to do is set those equal to each other. Let's see if I can get through this without making a mistake. This happens after Thanksgiving too. So I'm going to subtract 2Y from both sides, and I'm going to get 18 equals 2Y. I'm going to divide by 2, so Y equals 9. Okay, so that's my value of Y. And then for those angles, I'm just going to substitute it into the easiest one, because I'm lazy. And 4 times Y is 36. So those angles each measure 36 degrees because they're congruent. Right. So what did you learn today? We talked about the perpendicular bisector and its converse. We talked about the angel bisector, because it looks like I can't spell either. That's why I teach math. Bisector theorem and its converse, and then how to apply them. Okay. If you have any questions, get with me tomorrow in class, and have a great evening, day, whatever, whenever you are listening to it. And when you see the kids who stayed back from the field trip, because I know how some of you are, you want to watch this as soon as you get home from school, thank them for being quiet. Have a great day.